before we deep dive into the problem space and the solution space, I would like to share a small story with all of you, right? So this was a large Indian BFSI organization, and the way they are structured is in terms of organizing their teams. There are product teams, they are responsible for the operational systems, to build them, to evolve them, which probably serves the end customers, right? Then there is a centralized data lake team that is responsible for ingesting data from all quarters of the organization into their centralized data lake, right? So far, so with me. And then there are a lot of other data consumer teams who probably are working with the business stakeholders to create, say, BI dashboards or maybe train machine learning models to forecast and do a variety of consumption scenarios with the data that's provided by the centralized data lake team. And the consumption teams that were responsible for building the consumption use cases of, say, putting together visualization dashboards or training the ML models, as I was mentioning, right? Now, the ask was that one of these consumption teams had to put together the credit card customer onboarding journey and the offers that are associated with the credit cards. Now, in one of the business check-ins with the business stakeholders for this particular team, the business stakeholders very politely pointed out that the aggregations that the team was trying to project was not matching up. Now, don't ask me how did the business stakeholders knew that the data was wrong, but somehow when we are in the field, long enough, and when a new system projects the data out, somehow the stakeholders know that this data is not matching up, right? So they immediately pointed that flaw out, that these numbers are not making sense. Now started the arduous journey to debug this issue, to find out where is the problem, where is this data going wrong, why are the numbers not matching up, right? Now, what was the first point of act? We went to the centralized data lake team. Hey team, help us. The data is not matching up. What's probably going wrong? Now, to my surprise, or I should say as to my expectation, the centralized data lake team did not have any clue about what was going wrong, right? For them, they could not understand what was the problem with the freshness of the data. Was it problem with the completeness of the data? Was it problem with some of the technical problem? They just couldn't figure out the issue. They just couldn't debug. And please remember, all this while, the business criticality of those campaigns of putting together the credit card customer onboarding journeys are being put on hold because we are doing this debugging dance, right? Ultimately, this consumption team reached out to the actual credit card team that was responsible for owning a lot of source systems in the credit card domain. So think about data like credit card transaction data, the PIN set data, whether you are allowed to do contactless transactions or not, and a variety of other things that you can think and associate with a credit card, right? Upon talking to them, we realized that there were some problems, technical problems in some days probably the operational systems or the source systems were not completely on, or they were experiencing downtime, and due to that, some data missed getting into the pipeline and missed getting into the centralized data lake, and hence it was a data quality issue regarding the freshness and the completeness of the data, right? Now remember this, right? Like this might be very surprising for you, but that team did not even know that there is a downstream team which is working on top of their data to build such business critical information, right? So that's the gap that I'm talking about, right? It took 6 months to actually debug this entire one single consumption use case, and I'm sure you all are from IT, so you can do the math, right? In a large enterprise comprising of many, many consumption scenarios, if one problem takes 6 months to debug and identify, what would be the math for large number of consumption scenarios, right? Now, interestingly, some lessons emerged from this which are definitely worth sharing, right? That you cannot escape the Conway's law. Show of hands if you're aware of the Conway's law. Right, I'll explain it in brief. The Conway's law says that that the way your organization is structured is going to reflect in the way your systems are architected, right? So you can see in this case, the way the organization was structured in product teams, operational systems, centralized data lake team, consumption teams, and the complete gap, there were systems that they were architecting, and this entire value chain was ultimately broken, right? That was the first lesson. And we saw that in action, right? The second one is, as I said earlier, 6 months were lost. That's an opportunity cost in my mind, because that critical business campaign is being put on hold because the data is not matching up. Last but not the least, there is definitely a revenue impact, although I can't put together the numbers for you, but you can make that math that there is a revenue impact because one business critical strategy is not getting operationalized when it was supposed to, right? Now, having put this story in background, right, like keep this in your mind because I'm going to come back to it again and again. There is a sad truth that I'm going to present, that there are huge investments that are happening in the data and AI space, right? I'm not making this up. I can give you numbers. In my slide deck, I have attached a new Vantage report. It's an industry accepted and quite reputed report that gets created every year. When you get the slides, you can watch or look at the report yourself. According to this report, and based on the executives and the organizations that participate in the building of this report, consistently for the past 3 years, over 90% of the organizations believe that the investments in the data and AI space are increasing. Even in this year, when 2023, when we face the economic headwinds, right, yet close to 90% of the executives. Now, the kind of executives I'm talking about is chief data officers, CTOs, CEOs, pretty much who are in charge of the budgets, right? They believe that data and AI continues to be a strategic initiative for the enterprise, and hence the budgets are increasing. Yeah, that's a number here. Now, in this case as well, the story that you just heard, it was a big investment, right? The centralized data lake that I'm talking about, it was a move from their on-prem ecosystem to AWS. So this data lake was being built in the cloud. Now, if you ask me, what was the ROI on that, right? When for a single consumption use case, a business critical mission was put on hold, I would really, really question the value or return on investment on such large investments, right? And one of the other numbers that I would like to share with you in the same report is around establishing a data-driven culture, right? Now, if you look at the same report across the years for the last 3 years, close to 24% of the organizations, only 24%, I should say, only 24% of the organizations are claiming that they have been able to establish a data-driven culture. Now, you can imagine 90+% says that there are investments increasing, yet only 24 as an average says that they are able to successfully establish a data-driven culture. But the point that I'm trying to make here is that there is fundamentally something broken in this entire ecosystem, right? There is lack of return on investment on the value that we expect or the promise that these initiatives bring to the organizations, right? In this case as well, right? Low user adoption is another challenge. Now, in this case, the business stakeholders probably were polite, but that's how the trust erodes, right? You bring together false or bad data consistently to the table, they are going to lose complete trust in your new system, and they're going to go back to the way they were, computing or crunching their own data. And that's why I say that spreadsheets are still ruling the world because of lack of guardrails on these initiatives, and therefore the trust in the systems is not established, and hence people keep going back to how they are so used to crunching and understanding the numbers. Now, that's where I think slow time to market, we did cover that, right? 6 months waiting time. So these are some of the sad truths, but also the reality that we have across a variety of enterprises when it comes to the data and AI ecosystem. Now I want to make a hypothesis here, right? And that hypothesis is that data quality, right, plays a very important part in this entire equation, right? Because it's about trust, right? I think trust is a very overloaded term. I think we should really, really understand and deep dive into it. You cannot establish trust just by saying that this is a system built in the cloud, this is built with modern engineering practices, unless unless the people who have to consume that data really connect with that data. They can make sense of that data and they can trust, right? They can trust that data. Now, if that trust is not established, and therefore I say that data quality plays a very, very important role in being a critical success factor for all the data and AI modernization initiatives at any organization, right? And one more thing that I really request all of you to bear in mind is that data quality is not a technology problem alone, right? As against it's projected that data quality is just a technology problem. It's not. Data quality is also a mindset problem, right? Where we are talking about a mindset change. The data quality is also a process problem. How are the teams interacting and talking to each other, right? So data quality, in my opinion, is a holistic problem that needs to be looked and dealt with in that fashion only. And therefore, it's very important that we understand the data quality landscape, right? Now, what are the contributing factors that play a role in defining what the data quality is for a given organization, right? The first one is poor data quality at data entry itself, right? There are a lot of systems where data gets collected at the point of sale. If you go to a store, there is a point of sale that's happening, and the person who is selling and making the invoice for you is entering some data, right? That's a data entry, and at that point, a lot can go wrong. They can capture your spelling wrong, they can capture your date of birth wrong, they can capture your address wrong, and a variety of things, right? So data collection itself at the point of entry could be a problem. The second one is when we receive poor quality data from the third-party integrations, right? That's also a very high likely scenario. I'll tell you a particular experience that I have experienced at a variety of clients at ThoughtWorks. Whenever we are talking about ingesting or integrating with some external third-party data source, we want to talk about data contracts. But trust me, people on the other side never want to talk about data contracts, right? Data contracts, I'm sure if you are all data professionals, you understand that it's a term, it's a concept that's gaining a lot of traction in the industry, but yet very few organizations, when it comes to inter-organization data exchange, believe in that, right? And therefore, you could get extremely bad quality data from external organizations and have no clue on what's happening and why your computations or your views on top of that is getting garbled. The next one is absence of relevant data. Now, bad data quality is not just about the data that you have. Absence of the required data is also a contributing factor in your data quality landscape. The next one is biased data, right? Now, that's a very interesting one, quite close to my heart as well. When we have historical data and there are no guardrails or there are no measures on whether this data is going to be biased or not. Now, bias is I think is a very overloaded term. We can do another session and just keep on talking about bias and responsibility, but in a very simplistic term, in a very simplistic fashion, is my data, right, representing the kind of population that I have to serve, or the kind of ways in which my system is going to be used? I'm sure a lot of you might remember the fiasco that happened with Apple credit cards, and the credit scoring mechanism started giving low numbers to women, right? It started scoring women less. Now, Apple in its statement said that they did all the proper bias checks, right? The income and gender were not even there in probably in the feature set which was responsible for creating this prediction, but because of other features that were there in the data set that were curated from the data set, somehow the model learned that this person is probably a woman and hence started, ranking them low in their credit scoring. So you can see that even though you might see that you have perfectly good data, without the right data quality checks, from a bias perspective, you could be creating systems that are not inclusive and equitable for the entire population that we are talking about, right? Then, as I said earlier, that data quality is not just a technology problem, it's a mindset problem as well. And that's reflected in this point where we say lack of fixing data quality at the source, right? Once the product teams or the teams that manage the operational systems throw their data over the wall, they forget about it, right? It's not my problem anymore. I don't care about that data, right? And that's a mindset problem that I fundamentally challenge and question, that if I am a team and I am producing that data, how that data is being used downstream, is it not my responsibility? Am I not liable for making sure that that data is of high quality? But that's a mindset problem that we see, unfortunately, rampant in all the enterprises that I have worked with in my career. Okay, and again, in a very similar thought process, lack of domain-oriented validation. Now, think about it, right? I am part of a team. I understand my domain, right? I understand my bounded context. I'm sure a lot of you are aware of domain-driven design, so these terms are not alien to you folks, right? I understand my domain. I understand my bounded context. I understand what are the domain integrity rules that are applicable in my domain, but when it comes to data and analytics use cases or downstream consumption on top of my data, I just step away. It's not my problem. You figure it out. What is the domain rule that's associated, and you figure out how to manage this quality, right? So that's, again, a mindset change that I'm talking about that needs to happen. We will talk about, a lot more about it in the future slides. And last but not the least, but inadequate data standards, right? Inadequate data standards within the organization, right? I think that's a very big point. I'm going to deep dive into it in the next slides. But let's understand, as I said, from a data governance perspective, what is the relationship with data quality, right? Now, one could argue that data quality is definitely a part of the overall umbrella of data governance, but whatever are the other tenets as well of data governance, there is a very close relationship that I would like to establish with data quality. The first one is data ownership. Now, when you're talking about data ownership, I invite all of you to think about who owns this data, who produces this data. Does this data reflect the facts of the business, right? So that's a question that we should have in mind. The second one is data lineage. Where is this data coming from, right? How was this data collected? What are the sort of transformations that have happened on this data? What are the kind of teams or people who have had access to this data before it reached me, right? So that needs to be thought through when we think about the data quality aspect. Then comes data discovery. Now, where do I find the right data, right? A lot of times, as a data scientist or as a data analyst, if I have some hypothesis in my mind and I want to prove that with data, what is the first thought in my mind? Hey, do you think that as a data scientist or as a data analyst, I have a clear picture of what is that data that I'm looking for? No, right? There is a phase where I want to understand what sort of data is available in my organization, right? Who are the teams who are producing that data? But unfortunately, this is one place, right? Like, I'm sure all of you understand the data catalog as a system, but it doesn't exist, right? Even if it exists, it is not reflecting the true picture of the entire organization. So you can imagine that there is not a safe space or a place in the organization where a person who wants to prove or disprove some hypothesis on top of data can access that information to, right? So that's the discovery part. Then comes data provenance. I think nothing less than, can I trust this data? The same question that I was asking earlier, can I trust this data? Can you prove to me that this data is right? That this data is not tampered with, right? That this data is of high integrity, right? Can you prove that to me? And that's a question that again alludes to trust. Now, if I were to change this slide, I would put trust right in between the four sections that you see here, that trust is the factor that we are all driving these questions towards, because by asking these questions in our enterprises, we are trying to say, can I trust this data? Can I know who owns this data? Can I know who produced this data? And hence, make sure with peace of mind that now I can use this data to actually do what I want it to, right? And again, right, in the lack of data standards, in the lack of any sort of thought on how the data is going to be interoperating in my organization, if you're putting garbage in, you're going to get garbage out, right? This is grade 1 computer science. I'm sure all of you have read it, GO, right? It used to come in the acronyms, expand the acronym, right? Garbage in, garbage out, it still stands true, right? If you are putting in garbage, you are going to get garbage out at all times. And with that, I think this slide is not very visible, but I'll try best to explain this. When I say garbage in, garbage out, right, let's look at the flow of the data, right? How an enterprise unlocks value within their organization with the help of data. So this is the cycle of intelligence, right? What it says is that you have data. From that data, you create information. From that information, you create insights. From those insights, you identify what is a decision that I would like to take, and then you implement that decision into action. And then when that action gets implemented within the organization, it generates more data, right? So you see that this is a full cycle. And data quality, my proposition is that data quality breaks, if bad data quality, I should say, breaks or punctures this cycle of intelligence at multiple steps. Okay? The first one is incorrect decisions. Of course, right? Incorrect decision, like let's take an example. If the insight that is produced out of your system is wrong, it could mean that my pricing engine advisor, which is supposed to give the right discount deals that can amplify my revenue, creates a wrong deal, right? It might mean that I might decide to open up my next store in a suburb, which promised in the sheets or in the visualizations that this particular demographic is going to be your likely customer and the footfall is going to be high, the profits are going to be high. All a lie, right? Because that's a wrong decision that has been created, right? On that, right, again, I'm a big fan of putting numbers so that you folks believe me and I'm not making this up. Another number here is, according to a Gartner research, right, an average enterprise loses somewhere between $9.6 to $14.9 million every year because of bad data quality, right? Now, if you put together this alone in, say, the US, because that's where the research is coming from, it says that US alone loses $3 trillion every year because of bad data quality. So you can imagine that bad decisions definitely are bad for your business. There's a no-brainer about that, right? The second point is poor customer experience, and in some cases even adversarial customer experience, right? Now imagine, bad recommendations and I'm trying to buy something. I'm sure a lot of you must have seen the memes from Amazon, because it actually happened that when I was trying to buy a stool, Amazon started giving a recommendation of a fan and a rope. We can all, laugh it out right now, but then you can imagine that it is a terrible customer experience at the end of the day, right? Or another example on this could be, on a more serious note, in a healthcare system, right? Because of incomplete bad data, a wrong medicine being prescribed, right? Not only does it impact the health of the patient, but in some cases it can also lead to death, right? So the bad outcomes for the customers range from, terrible experience to even adversarial experiences for our customers. Regulatory non-compliance, right? Now that's another interesting one, right? Do you know that in the year 2020, Citibank was fined $400 million on the back of their data governance posture, primarily because of their data quality standards, right? You can go and read up about that. So what I'm trying to say is that data quality is impacting almost all parts of your data ecosystem, and it is something that we all need to pay attention to, right? Employee productivity, again a simple number. Data scientists or data teams spend around 40% of their time debugging and identifying data issues or bad data issues for that matter. Imagine if we had the right mindset and imagine a hypothetical world where we have solved the data quality problem, the amount of bandwidth that's going to be freed up on these teams to invest in creating business critical information or synthesizing business critical insights, if all of this time was not being spent on useless debugging things, right? And last but not the least, right, erosion of trust within the organization, right? I think that's an underlying theme across my presentation. And if you look at this problem, from a data architecture perspective and the way the status quo is today, right? This is how the data architectures look like today, right? There is the operational data plane, which is the systems on the inside, right? The ones that are responsible for serving your end customers, right? Running the business and serving the user. So this is your operational data plane where your operational systems are managed. On the right-hand side, we have the analytical data plane where we have the analytical systems or the big data systems which are powering, say, your internal users, your data scientists, your data analysts, your business stakeholders, right? And the idea there is improving the operational efficiency of the business, creating new hypotheses or proving and disproving new hypotheses, right? And in between, you see the accidental complexity of large data pipelines, large ETL pipelines that cease to be pipelines after some time. They become pipeline jungles, right? Like you make one change in some end and you're just sitting and praying that it doesn't break 3 other downstream systems, right? So it becomes the jungle in between, and that's the accidental complexity that we are talking about, right? That cost of change is so high in such systems because the central team doesn't have any clue of what does this data mean? What is this data that they are working on, right? Now, that's reflected much more in the next slide, which says there is ubiquitous data in your entire organization, right? There are the variety of digital initiatives, there is variety of data that is getting generated, that is getting produced. There is a centralized team, and then there are lots and lots of questions, right? There are a variety of consumers on the other side who are trying to ask multiple type of questions to the same team in between. You see the sad faces there. I think, they are the saddest lot. If one of you happens to be part of such a team, I can really empathize with you that this team is the most overburdened and most neglected team in the organization because they are serving conflicting requirements, right? In fact, I even invented a very interesting phrase that because they are the central team and they have to talk to different variety of consumers who have very conflicting requirements, the innovation agenda becomes in-queue innovation. Like you are waiting, your request will be processed in some time. Have you heard that IVR message? Something like that, right? So the innovation agenda is sort of on hold, is in queue because there is a single team that's trying to serve the variety of requests that's coming their way, right? Now, if you look at the inverted triangle at the bottom, it talks about fixing data quality from left to right, right? The cost from the source teams increases exponentially as it reaches the consumption side, right? Now, there is a simple research or a rule that says 1, 10, and 100. Have you heard of it? 1, 10, and 100 rule. What it means is that, again, take these numbers with a pinch of salt, but it's enough to explain the concept, right? That it takes probably $1 to fix the data at the source, to fix the data integrity at the source. It takes probably $10 to fix the data probably when it's getting aggregated. And it probably takes $100 to fix the data in a 2-hop or a 3-hop downstream system. So you can do the math that as you move away from the source towards the consumption scenario, the cost of fixing data quality increases exponentially. And that was very visible in the example that we heard. It took 6 months. It took 6 months to get to the bottom of that issue. Now, is all lost? Not all is lost. I think there is again a good news. In the same report, again, the executives believe that data quality is an important initiative, and hence 78% of them believe that they would want to invest in data quality in their organizations, right? I think at least I'm happy about that number. And before getting into the solution space, right, let's take a brief look at the data quality tenets, right? What are those characteristics that are associated with good data or with data for that matter? Let's take an example, say for timeliness, right? Imagine a healthcare system which is sort of taking input of your blood glucose levels to predict your likelihood of getting a cardiovascular disease. Now, the timeliness aspect is that the reports for this particular context should not be older than 3 months, right? So that's a timely timeliness aspect, right? Now, you could have a report, a perfectly valid report, but if it's 1 year old, it doesn't serve the purpose. It still is bad data because it's old, right? So there is a timeliness concept or aspect that's associated with data. Then the other one, say, is consistency. Now, if I'm an e-commerce application, if I'm an e-commerce organization, I would want to have my invoices in a standard currency, right? And I think that's a consistency aspect that I'm talking about, right? I would want to store my datetime or my other ISO standard formats in a very standardized format so that it's consistency across the organization in terms of the data capture and the data quality, right? So these are some of the tenets. Rest of them are quite self-explanatory. I'm not going to get into them, but please keep these tenets in your mind as we go along. And with that, I would like to present the principles of data mesh. Right now, my invitation is don't get bogged down by the word data mesh, but focus your attention towards the principles because they are the most important ones. The first one is domain ownership. Now, I think I've given set enough context of what this could mean, but domain ownership means that if I am a team that is responsible for the operational systems, right? Say if I'm the credit card team, I have several source systems that are responsible for serving the end customers from a credit card perspective, right? If I'm owning my operational data, I should also own my analytical data. Please pay attention. This is a very important thing that as a team, if I am owning my operational data, I should also take the ownership of managing and controlling my analytical data, right? So that's the domain ownership part. This is where the decentralization is coming, that versus a centralized team owning your domain data, you are owning your domain data yourself, right? You are responsible for understanding what are the various consumer needs for your data, and you are responsible for making that data available, right? So that's point number one. Second principle is data as a product. Now, I think in the operational world where we all happily talk about microservices, creating fantastic systems, thinking about domain-driven design, we have brought product thinking into the operational realm, isn't it? Like happily we have built systems which talk about product thinking, right? Long-lived product teams, building microservices, right? Owning only a section of the microservices and not the entire monolithic application, right? I'm sure all of you are aware of it. But when it comes to the analytical data, where does that thought process go? It just vanishes into ether, right? And my proposition here is, with this second principle, that also start to bring that goodness of product thinking to your analytical data as well, right? Start owning what are your consumers, who are your consumers, right? What are their needs? What is the way in which they expect this data? There is a Neo4j stall or a booth outside. Do they need this data in a graphical format? Because there is a lot of relationships in my data, and therefore they would be more willing to answer questions. Tell me about what are the top 5 products in the last 30 days. Or do they need, a more JDBC oriented data? Do they need a more, do they need a BI dashboard on top of it? Like, what exactly is the way in which they are going to consume my data, right? So data as a product is about understanding the consumer needs, creating a delightful experience, and making sure that your consumers are able to find the data in a very safe and trustful fashion, right? So that's the idea of data as a product. The third principle is self-serve data infrastructure platform. Now, decentralized ownership doesn't mean decentralized infrastructure. I think we're not saying that you create your own pipelines, you create your own infrastructure, you create your own Spark clusters, or you create your own Kafka cluster per product team. No, that's not the idea. The idea is that the self-serve platform team is going to identify the list of platform capabilities that are relevant for solving, say, 80% of the use cases in my organization, right? And they are going to do the heavy lifting in providing those platform capabilities, but the product teams can always leverage those platform capabilities to build their data products. So here the connotation is about how can I democratize ownership of analytical data to the product teams by building the platform capabilities in a fashion that it's available for all the product teams, right? So that's the aspect of a platform. I think if you look at a lot of ThoughtWorks material on the website, we keep talking about platform as a product, right? In a very same spirit, the self-serve data platform that we are talking about is building this platform as a product for your internal consumers, which are nothing but your product teams, right? The product teams who can now, besides building their operational products, can also start to build their data products, right? So that's the proposition here. The last principle that's very relevant here is federated computational governance. Now, there are two words in this three word phrase that I want to bring focus on. The first one is federated. Now, federated means that this is not a command and control kind of governance. There is not one single entity that's sitting in the center who is deciding how should the data interoperability look like, how should the data standards look like. There is consensus, right? There are people from the domains who are participating in creating these standards, right? So there is a federation concept, there is a consensus concept that we are trying to evangelize, that governance is not command and control. Governance can be done in a federated fashion such that it has much more buy-in from the product teams who are actually going to be implementing those regulations, right? And the next word is computational. Now, computational means how can I automate a lot of this feedback on the regulatory and compliance related aspect with the help of my self-serve data platform, such that my product teams can get that feedback early on, right? That we are not waiting for a breach on a compliance perspective to happen, but it's much closer and shifting the process much more left towards while the data products are being built itself, right? You would notice that these four principles, they work together, right? They facilitate each other, right? And that's the beauty of this entire thing, that they hold each other together. And if they are implemented in a fashion that they are facilitating each other, it's going to help us think about data quality better, which is what I'm going to talk about next. On the first one, right, domain ownership. Now, what I'm trying to say here is, if we are looking at decentralized domain ownership for the analytical data as well, there is going to be high integrity of data, because there is going to be solid understanding of the domain quality rules, right? Now, if you go back to the story that you heard in the beginning, the credit card team, product team, now they understand that transaction data is much more voluminous, right? There is much more transaction data than a PIN change on the credit card, right? So both of these source systems or data sets need to be dealt in a different fashion, right? The freshness component of transaction data and the freshness service level indicator on the PIN set data are different, right? Because probably the transaction data can be used in predicting fraud, right? So it's a much more near real-time requirement on the transaction data versus any other data point. So you get the point that if I am a domain and I am owning my analytical data as well, I would be better able to identify, based on the needs of my consumers, what sort of rules apply for my data quality, what sort of rules can actually help in elevating the data quality, right?
I have one quick question on this. So when you talk about the domain owners and decomposing the analytics scheme and bringing that ownership back to the core data, the domain data, many times it happens that the core data, suppose credit card, for example, of you taking, though I have a question that it's a PCI data and supposed to be audited before it comes in such a bad state, but I don't know if it didn't happen, why it didn't happen, but keeping that aside, if that didn't happen, the CSOs or the top leaders, it may not be just needed, they may not just want to see the transaction data, they might want to see the transaction data which may be which part of the city or the country
I'll come to that.
Happening. So it's a mix of multiple
Yes.
domains, it's not just one domain.
I'll come to that.
Someone has to merge that, and I guess that's why that CMS is.
I'll come to that.
Okay.
I'll just hold on that question in your mind. I'll come to that, right? Now, effectively detect and manage bias. I think I was giving this example, or I'll come to that, I promise. Effectively manage and detect bias. I think I was talking about the Apple credit card example earlier on. And imagine, right, if I'm a team and I understand that my data is going to be used for credit scoring for customers, can I then start to think about what are the right bias related data quality checks that I want to provision in my domain, right? When the features that I'm creating, right, the features that are used in the model training and they contribute to the prediction that the model is going to, create when it goes to that inference phase, right? How can I not have features over-indexed, say on income, say on gender, right, or the ethnicity of a person, right? So as a team, I am thinking about all of those aspects of how can I detect bias in my data based on the consumption scenario that I have to sort of fulfill, right? And most importantly, right, I think that's my favorite thing, that fast turnaround time when something is broken. Because I have full ownership, right, because I'm claiming ownership on that data, it becomes my problem if something is broken, if something is faulty, right? It's not that it is someone else's problem and somebody else is looking at it, right? It's my problem now. I will make sure that the quality is fixed, the quality is ensured, and we are talking about it. Now, coming back to the point that my friend here asked, right, what is the purpose? The value of the data, definitely we all understand, comes in joining and aggregating, and that's why I think we think about centralized architectures. But now I'm going to show you this sort of a map here, right? There are source domains. So these hexagonal boxes that you see here are, think of them like data products, right? This is not a true data mesh session. Otherwise, I would have spent a lot more time on that. But in the spirit of understanding what I'm trying to say, let's take an example to understand this better, right? Imagine an e-commerce sort of a setup, right? There is, in the source domains, we have teams, say, who are managing the order returns, right? Now, when there is an order return, there are return codes, right? For every return that you do, there is a return code or there is a return reason that needs to be there, right? So that's one source domain. Let's imagine. The second source domain is the team that's powering the product information systems for my catalog, right? So that's my second domain here. And please bear in mind that I'm using the word domain loosely. I mean a bounded context here more than a domain, right? Because a domain can have multiple subdomains, and those subdomains can have multiple bounded contexts, and the mapping to the team is immaterial for this conversation, but understand that as different data products, right? Now, these are the two source domains: product information, which offers information about can this product be returned? Can this product be returned in, say, 20 days, 30 days? Can this product be replaced? Can this product never be returned, right? Like, there are rules associated with different types of products, categories of products for that matter, right? So that's the source domain part, right? Now, if as source domains, I am making sure that I am providing my downstream teams or my downstream data products trustful data. They can trust this data that's coming from source domain 1. They can trust this data that's coming from source domain 2 because I am owning that data up in its domain reality by applying all the data quality rules that my domain should uphold, right? Now, the second layer here is the intermediate consumption domain, right? That's where the aggregation comes in picture. Now, probably I want to look at a use case where the product categories and the return codes need to be mapped and aggregated. I want to see what are those categories of products which have XYZ return code, right? Like, I did not like the fit. That could be a return code and that could be a valid reason. How many products, in what categories? And there are many ways I can slice and dice this, right? So that's my second data product here, which is responsible for this sort of information. And this particular data product in this second line is ensuring that this slice and dice is presented in a way that my downstream requires, right? And that's where we come to the fit for purpose, this one, fit for purpose model data products, where I'm saying that tell me in the last 30 days, what were the top 5 product categories and the top 5 return codes that were sort of addressed. And that can then further go to, say, an internal report or a visualization dashboard, or maybe even to forecast that what are those products that likely end up in a return, right? So I might want to prune them in my recommendation list, and therefore this chain goes till that point where that model is being trained to identify and figure out what are those products that can likely end up in a return, and hence I might not even want to show them to my customers as a recommendation, right? So you can see the entire value chain sort of exploding here, right? And the beauty of this thing is that there is a chain of trust, right? Not a single. Now I'm not making any, claims about who owns all of these data products. Based on the shape and structure of your organization, it's possible that one or more of these data products are owned by a given product team, but it's also possible that all of them are owned by a given single product team, because that's how the domain and structure is happening, right? But what I'm trying to tell you is exactly your point, that aggregation is happening, but it's happening in a place, in a safe space where the domain knowledge is not lost, right? Where the rules of the domain are not lost, and that sanctity of data is maintained, right? Like when we make a human chain, what is the recommendation? Believe the person who is just behind you, right? Just focus on that connection, and the rest of the thing is going to be taken care of. In a very similar, thought process, this is establishing a chain of trust, right? If the intermediate consumer domain trusts the source domain, the fit for purpose model data product can also then trust the intermediate consumer domain, right? And I'm going to show that all of this is completely transparent, right? All of these data products are probably listed in some data catalog. All of these data products are explaining their metadata properly. All of these products are explaining their service level indicators in a very transparent fashion. When was the last time the pipeline was run? What is my freshness? What is my completeness? Do I have missing data? All of those things are transparently available, which we're going to come to in a bit. But let's take a look at some of the domain level tests that are relevant, right? In a very similar spirit of the test pyramid that we all are very familiar with, the domain level test from a data perspective includes the unit test for your transformations. Now, there are some tests that you write while you're building the data products, right? While you're writing the transformations. So they are the unit test for your transformations, right? There are also the unit test for your engineered features, right? When you're curating a feature for preparing for further use, say in a model training, you are also writing a unit test on that, right? Then there is data feature validation, right? Where we are talking about there is adherence to schemas. Can my features be actually used? Is there schema versioning happening? Am I backwards compatible to what I had produced earlier, right? And last but not the least, at the data pipeline level itself, right? Now, if you look at the pyramid here, the number of tests go on decreasing because it starts to become a lot more costly as we go up the ladder, right? Now, at the data pipeline level, I can, in my lower environments, create integration tests against small set of data, right? It cannot be production data because we all understand that using production data for lower environment testing is an anti-pattern. But can we create data that looks like my production data and use that to test my integration of the entire data pipeline while in my production system itself, right? While in my deployed lower environment itself. And that's how the view is going to look like, right? Now, in your path to production, where you are taking your data products through the phase of development, right? In your developer machine itself, where you're writing unit tests by mocking the data, right? The next step is when it gets into the CI/CD pipeline, not the data pipeline, the CI/CD pipeline where the data product is being built and then probably it will be deployed, is the part where again the unit tests for your transformations are being run. It gets deployed in the pre-prod or a lower environment, and that's where, right, you are trying to mock production-like data. Now, there are a lot of tools that help create production-like synthetic data, right? In the current edition of the Radar, we put up Synthetic Data Vault. Again, we don't have any affiliation with that, but it's a fantastic tool to generate production-like data because it learns the statistical properties of your production data and creates fake data such that you can use it in your lower environments for testing, right? So that's where you can do the flow test based on what are the steps in your data pipeline and are you getting the same sort of results that you expect your actual production pipeline to get to, right? data quality checks. You can do a lot of exploratory testing, anomaly detection, all of them automated, by the way, right? They are automated, and the underlying part here is there is data observability and there is data monitoring, right? There are lots of fantastic tools, again, coming up in this space. Monte Carlo is one of my favorites, which we have used in a lot of engagements, right? It allows you to look at what is the state of a data pipeline, right? If there is bad data based on some threshold, the pipeline would stop, right? And then you can look at what is the problem, traces. All of these are practices that we need to now bring to the data ecosystem as well, such that we can observe our data really, really well in production. The next one is data as a product, right? Like this, I'm trying to connect how data quality sticks with the data as a product principle. The first one that I would really want to say is, as I said earlier, knowing your customer, knowing their needs, right? The example that I gave earlier about the freshness of the transaction data versus the freshness of say the pin set data, right? The SLIs or the service level indicators are different, right? Because my consumption use cases are different. Similarly, quality rules as per the purpose and context of the consumer. So as I was telling earlier, right, in the example of timeliness, having absolutely right data can also mean bad data if it's not adhering or it's not satisfactory for the purpose for it's being used, right? So the purpose and the context is the most important aspect when we are thinking about data quality, because data quality is not just about, okay, this data looks okay, this data is abiding by the type confirmation, this is a unique ID. No, right? If it's not appropriate for the context in which it is being used, then it is still going to be called as bad data. And the most important part here, as I was mentioning earlier, is making the data quality or quality data discoverable within the organization, right? In a seemingly frictionless fashion, right? And that's where I think, you know, these are some screenshots from some of our live projects where we are demonstrating that how this can be done. Data as a product facilitates that as a consumer, I can now discover the data products, data sets, and request for access. You can see this small screenshot here from Apache Atlas, right? Where as a data consumer, I can discover my data products, right? I can figure out what is the metadata that is associated with each of the data product, right? And understand what are the SLOs associated with them, right? In the second screenshot, you can see what is the lineage that I was talking about. Where is this data coming from? What are the kind of transformations that this data is going through? So you can see in this diagram here that when it comes to the last data product where we're talking about the insights batch, this is the sort of transformations that my data product has gone through or my data has gone through, right? Here, this part shows an aggregation. You see this? This invoice details is taking data from order placed event as well as this customer order, right? So there is aggregation in the system, but there is also a way in which we are, in a very trustful fashion, in a very transparent fashion, making that information available to all the internal users of the data within our organization, right? The self-service data platform, right? I think this is where it becomes very, very interesting that not everybody has to think about building their own data quality frameworks, right? The self-serve platform team can do that heavy lifting for the rest of the product teams, right? So we are still talking about there could be, you know, a central platform team that is still taking care of building these platform capabilities that are relevant for my product teams, right? Now, one of them could be, I'm sure if you are a data professional, you have heard of the tool called Great Expectations, right? It helps you do data validation checks and data quality checks on top of your data. Now, in one of our engagements, we built the data quality framework as a central capability. Now, imagine when I say a central capability, it means that there is a platform capability which is provided, but it doesn't own the data, right? The data is still owned by the product teams. They define what are the rules, but the platform allows them to author those rules. The platform allows them to make sure that there is an isolated environment for each data product to execute their rules, right? I think that's a very important concept to understand, that we are not against platform teams or central teams, but those teams should do the work that they are designed for, that is create infrastructure in a way that you can present it in a very isolated and a multi-tenanted fashion to your product teams and not try to own up that data yourself, right? I think that's the distinction that I'm trying to sort of get to, right? Similarly, the central team itself can make sure that they provide a data cataloging capability, right? As a platform capability, I will make available a highly available data catalog to which all my product teams can publish their data product metadata, right? Now that becomes the safe space for the rest of the internal users in my organization to find the right data, right? Then data observability, data as a product. Now, if I'm building a product, right, would I miss what are the consumption scenarios for me, or what is the value that my product is adding? When I think of a product, right, when we think of a product, we think of what is the problem that this product is going to solve, right? Now, the product requirements can evolve, right? We all know that products can evolve, but whatever is the required problem that we are trying to solve at that point of time, that should be completely baked into the system. And the data quality rules that the data product is implementing should make sure that all of those checks are verified, right? So nothing is left to, if there are more types of credit cards. Today, my product is supporting 4 types of credit cards, and I am presenting that information very transparently to you, that these are the 4 types of credit cards that are supported, and these are the rules that validate that, right? So I will make that information available to you in my catalog, where you can make that decision whether this data is right for you or not. So you see that data as a product is the one that helps solve the problem that you exactly mentioned. Yeah. And similarly, data observability, data lineage, all of them can be platform capabilities that the platform can provide, which can be used by the product teams. And this is an exemplar architecture that we put together. As I was mentioning, this is a platform capability right here. And the source teams used to supply their information, their query rules, and the platform used to ensure that the rules are executed, the data quality checks are created, and then only the data is being populated in the isolated storage for that particular data product. Now, this is again a very simple dashboard that we created for one of our clients, where we have variety of, you can see that there are variety of data products here, right? Each data product is publishing information like, am I addressable, right? If I am an S3 bucket, if my data product is providing the output in an S3 bucket, is that S3 bucket addressable? Can I access that S3 bucket, right? So that's the addressability part. Am I discoverable? Is this data product available in the catalog, right? Is there a unique identity in the catalog for this data product? Is there an owner for this data product in my catalog such that I can initiate conversation, right? And is it trustworthy? Is it self-describing, right? So all of these information can be made available to the organization in a very transparent way with the help of the self-serve data platform. And this is again a very simple exemplar self-serve data platform that we have put together for one of our clients. Right? You can see the components here. I'm not going to go into them, but this is just to give you an idea, right? All of these components that you see here were made available to the product teams in a multi-tenanted, isolated fashion, right? So one team's data products were not interfering with another team's data products, but the platform capabilities were built by the centralized platform team itself in a very product-oriented fashion, right? On a product-thinking fashion that, okay, what are your requirements? I will try to create my backlog based on what are the requirements for my data product creators, right? And the last one is federated computational governance, right? How can I establish mesh-level data quality standards? How can I establish mesh-level data classification standards, right? How do I classify PII data, whether it's highly sensitive, whether it's medium, or any other vocabulary that I use in my organization? Globally applicable quality rules, right? By default, I want to automate that any PII information, any field that's tagged as PII should be encrypted in my self-serve data platforms, data storage created for a given team, right? Naming conventions for my glue IDs, and then computationally embedding that feedback into the ecosystem, right? I think that's the most important bit, that how can the teams get automated feedback? Because without the automation, I think scaling governance is a very hard problem, right? Now, more and more organizations are looking at tooling which can help them automate a lot of their governance challenges. And that's where I think we believe that the self-serve data platform can help facilitate and automate a lot of the governance challenges with the help of the platform that I spoke about earlier. And this is like the end-to-end view on this. There are source systems, there are source domains who are exposing the source systems data using some common vocabulary for the organization. There are consumption domains, right? They are exposing the business entities which are abstracting away the source domains, right? The aggregation example that we spoke about, right? And then there are fit-for-purpose domains which are again exposing data to serve a very specific use case in a highly performant fashion, right? So all of them are different types of domains within the organization, and they create different types of data products, right? Now, if you notice at the bottom, right, quality is being shifted because I provide that quality feedback to my previous in the chain and so on, and that's how, you know, there is close collaboration on whether I'm providing quality data to the downstream teams or not, right? I think that's a very important aspect that I want to drive to, that how can we shift the data quality left by bringing in this thought process of everybody starts to own their data, and that's where, you know, with ownership, with right domain rules, with right self-serve platform capabilities, we are able to solve these problems. Last but not the least, quality is not an accident, right? It's always a result of intelligent effort. And I'm sure you will agree, if you have been part of a data quality initiative, that it's a lot of effort to actually solve this problem at scale for a large enterprise. And yeah, that's about it.